So beginning with problem number 4, your teacher will provide you a handout with a bunch of pieces that need to be cut out. So as the directions state, in your groups of 2, you're going to take turns matching pairs of cards. Identify 2 pairs that are possible in the unit circle and 2 pairs that are not. And then for each pair, explain to your partner how you know that if the pair is or is not on the unit circle. So the cards will look something like this. You'll cut them out, and you're supposed to select information so that you know whether it's possible or not possible, and with respect to it falling on the unit circle. So you're given some sine, some cosine, and as well as quadrant. And then if you and your partner don't agree in terms of that discussion, then continue that conversation and try to reach some type of agreement. Problem 5 is asking you, once you and your partner have identified 4 pairs each, pick one of your possible matching pairs and calculate the value of the 2 missing trig functions for that match. When you finish trig calculations with your partner, and check to see if you agree with each other's work. I'm going to begin our discussion with problem 6, and then to the end of the activity. In this activity, definitely a lot of new things. We're going to be looking at tangent function and in a way that you've not looked at it before. So make sure you're taking really good notes, because you will definitely see this tangent problem show up multiple times over the next couple of lessons. All right, so in problem number 6, tangent of theta equals 2. The angle measurement is the first quadrant. So what is the values of sine and cosine? So we know both of them have to be positive. So probably has a little more room to work with. We also know that the sine of theta over cosine of theta can replace tangent. That's kind of the rule we talked about this past week. So I could replace tangent with sine of theta over cosine of theta. And if I cross multiply, what I end up with is the sine of theta is going to equal 2 times the cosine of theta. So the reason I'm doing this is because we have a Pythagorean identity, which states that the sine square theta plus cosine square theta equals 1. So if I replace tangent with sine and cosine and then cross multiply to get either sine of theta or cosine of theta equal to something, we can do a substitution here and actually be able to solve for one or the other value. So in this case, we're saying that sine of theta is equal to 2 times cosine of theta. So we're going to replace sine of theta with 2 cosine theta. So we're going to have 2 cosine theta, and we're going to square that. So again, when we're doing this substitution, we're not replacing the 2. Plus cosine square theta equals 1. So when doing this, that exponent of 2 is being applied to both things. So 2 squared is 4 cosine squared theta. So we have 2 squared and then cosine squared. So that's 4 cosine squared theta plus cosine squared theta equals 1. So here I have 4 cosine squared thetas. Here I have 1. So altogether I have 5 cosine squared thetas equals 1. Since this is a multiplication problem, I can divide both sides by 5. So cosine squared theta equals 1/5. So cosine theta is going to be plus or minus the square root of 1/5. Since we are in the first quadrant, then cosine theta has to be the square root of 1/5. Has to be the positive. So if you stick it in your calculator, we get approximately 0.447 is our answer. So to find sine theta in the first quadrant, we know that sine theta is 2 times cosine theta. So since cosine theta is approximately 0.447, then we can take our answer for cosine theta, and based on this, we can double it. So sine theta will be approximately 0.894. So that will be our answers for cosine theta and sine theta. All right, so in problem number 7, it's asking for the value of tangent at 0, 1 and 0, negative 1. So keep in mind that this is cosine and second value is sine. So tangent, by definition, is our sine theta divided by cosine theta. So therefore, for the first one, it would be 1 over 0. And if you take 1 divided by 0, you're going to get an error in your calculator, so this is undefined. And the second one, it would be tangent of theta is equal to negative 1 over 0. And again, you'll get also another undefined answer. In other words, if you divide that, you'll get an error. In problem 8, again, tangent of theta is equal to sine of theta over cosine of theta. So that's going to be 0 over 1. So for the first one, the answer is 0. It's one value. And if I do tangent of theta equal to 0 over negative 1, that also simplifies to 0. So in problem 7, the value of tangent is undefined because you cannot do division by 0. Problem 8, the value of tangent is 0. All right, so before I talk about 9 and 10, I'm going to go back to problem 7 and 8. So if I was to plot 0, 1 and 0, negative 1, this would be a vertical line in terms of the points. So just kind of a reminder that vertical lines, slopes are impossible. And then from 1, 0 to negative 1, 0 going this direction, that slope there is a horizontal line is 0. So again, I want you to understand that the answer I'm getting here actually tells me the slope of the line if I connect these 2 points, and the slope of the line if I connect those 2 points. And here they're asking, are there any other points that will give you either a 0 or a doesn't exist? Since all the other points on the unit circle are going to have some value either that's not 0, so it's either going to be positive or negative, but in both cases they're not 0. Then you're never going to get a 0 answer because neither number will be 0, and you will always get an answer because again you're not dividing by 0. So for all the other points that you choose, there will be some answer that's not 0 or doesn't exist. Problem 10, cosine is negative half. And the angles in the second quadrant, what's the value of tangent and sine? So if I do cosine square theta plus sine square theta equals 1, we're told that cosine is negative 0.5 squared. Again, if you're uncomfortable with the sine square theta, you can always replace sine theta with y. So this is 0.25 equals 1. And then if I subtract, I get 0.75. And now I take the square root of it, I get plus or minus the square root of 0.75. We're in the second quadrant, so that means sine, the y value, will also be positive. So the final y answer is going to be y is equal to the square root of 0.75. It's going to be positive since you're going up. So we end up with 0.866 as our approximation for y. For tangent is equal to our sine answer divided by my cosine answer. So our sine answer is 0.866. My cosine answer is 0.25. So 0.866 divided by 0.25, and our tangent answer is approximately 3.464. Your teacher will be giving you a handout for homework, so you can continue working on those problems in a group if you like to, and then I will take any questions you might have on the homework assignment upon my return.